Hey everybody, this is Mrs. Slauson and we are starting 1.4 in our notes package, and this is page 18. So in 1.4 we're going to start looking at linear functions that have a restricted domain, and that's what we're going to be calling them for this moment, but eventually we're going to move into a different name where they're known as piecewise functions. So where I want to start is kind of just skip this first part for now and just remind you that you do know how to graph a linear function. And so what will be helpful in this particular section is that you have a pencil and a highlighter. So yeah, grab that pencil if you don't have one, and pause the video and then we'll get started. So I'm going to be starting right in the middle of page 18, and what we're going to be talking about here is just a reminder of how you graph a line. So this is the function that we are graphing. It is a linear function. And as I told you in 1.3, we're going to begin with the number that's by itself, which is this -1. And that is right here. And then I'm going to get some more points by using my m, the amount that's married to x. And we need a rise over a run, so our run will be 1. And then just as a reminder, one of the common things that gets messed up when we do start looking at these things known as piecewise functions is the direction of the line. So just a reminder that this line will be going up from left to right. So I'm from here going to rise 2 and then run 1, and I'm going to quickly fill up my page with as many points as I can. And that is very important in this section, that you fill up all the points. Now what I don't want you to do is connect them yet, because what we're going to do is address this domain restriction. Remember, domain refers to the x's. And this is saying, take this function, go ahead and graph it, but we're only going to be using the portion of the graph where x is greater than 2. So if you remember, we have been doing this framing out with note cards whenever we use domain. And so I would frame an x amount on the left and an x amount on the right, and we would make that frame. So here I'm still going to kind of be framing it out, but I'm going to go to where x is 2, so right on the edge of this card, and I'm going to use my highlighter this time to make that frame. All right? Maybe you can hear the band playing in the background. And according to this, I want the portion of the graph, either the left side of my highlighted line or the right side. But based on this, it's saying we want to keep the portion where all the x values are bigger than 2. And if you notice here on this side, this is where the x's are bigger than 2. So this is the part I'm going to keep. And I'm going to take my pencil now and erase all of these other points that I don't need. And then, starting on that highlighted line, I'm going to connect and go up. So normally in a line, we also have arrows on both ends. Well, I'll still have an arrow on this end because my line will keep going. Even though the graph paper is ending, it's still going to keep going. But on this highlighted line, which we can kind of refer to as a boundary wall, as our picture frame, I'm going to be putting an open circle because this says I want everything that's bigger than 2. So I don't actually want to include 2, I want bigger than 2. And what an open circle allows you to say is to say, you know, it's close to 2, but don't include 2 because we want everything greater than 2. So let's practice that graphing again, and then we'll answer the second part. So for this function, the number that's by itself is the 5, so I will be beginning at 5. And then my m, my more points, is a -2/3 slope, which as a reminder means my line should be going downhill. So from here I'm going to rise 2, but then I need to run left 3 to get that downhill look. But I'm going to keep this up and fill my whole graph with functions. And again, I'm not going to connect them, I'm just going to leave them for now. And here what's going on is I'm going to look here at my domain restrictions. And so here I want to make a frame at -3 and 6, but I'm not going to leave the postcards. I'm just going to take my highlighter and draw in my frame. All right, and when you see inequalities that look like this is review, this means between. So I want to graph the line so that's between -3 and 6. So I'm going to go ahead and connect my dots. Luckily, I actually don't have to erase anything because I didn't go past those highlighted lines. And this says, you know what, don't include -3. We want all the x values that are bigger than -3. So to show that I don't want to include -3, I do an open circle. But the fact here, it says, make sure you include 6. That's what this underline means, less than or equal to, which means we're going to include it. So when I want to include it, I'll put a closed circle. Now, if you don't put a circle, that automatically implies that it is closed. So if I had not put anything here, that would be okay, but I definitely have to show the open circle here. So let's go back and let's talk about evaluating. So remember, when I give you the value in the parentheses, this is me saying if x is 4, if x is 0, if x is 2, what's y? So the directions say use the function to evaluate, here are my functions, if possible. And we haven't had that word pop up yet. So my function, if x is 4, I just want to go over to where x is 4, and if I go up, I can see that that's 7. Now, just a reminder, I don't have to use the graph to do that. I could actually use the function and put my 4 in here. So 2 times 4 is 8. And when you take 8 and subtract 1, you will get 7 as well. So you don't always have to use the graph. You can use the function. Now, if f is 0. So if x is 0 and I look, remember, we erased these points. So there's actually no function over here. So this is one of those answers where it's not possible. So for now, I'm just going to write not possible. And then the last one, f of 2. So let's go to where f of 2 is. So I'm going to go to where it's 2. And when I showed this to the students in the classroom, they said 3. And then I said, no, it's not possible. And then they remembered that the open circle says, you know what, don't actually include 2 in your domain. So I shouldn't put 2 in here. I mean, I can and get a number, but it won't work because I don't want to include 2 as part of the graph. So the only one that actually worked was this f of 4. So when we go to this one, h of -3, notice it's an open circle. So I should not be giving a solution. It is not possible. H of -2, well, that's in here, and that is 6. Oh, it's actually not quite 6. It's about 6 something. So let's say 6.2. If I do want the exact value, I can always take the -2, put it in the function, and then do the math. So in order of operations, I would do my fraction first. So I would get -4/3, which, if you remember, as a mixed number, that's -1 1/3. And then if I have 5, and then this is a subtraction of a negative, so that's actually going to become a positive. So this becomes 5 plus 1, which is 6, and 6 plus 1/3 is 6 1/3. So that's the actual exact answer. All right, h of 6, let's see, is that possible? Yes, because that is a closed dot, and if x is 6, then my y value is 1. All right, so that's with just graphing domain restrictions. So from there, let's take a look at some of these word problems. All right, so before we do that, I do want to visit this part right here at the top of page 18. And back in the previous lesson, so when it says the previous lesson, we're referring to 1.3, we had a problem that represented the bank account, and so I'm going to show you where that is. But it says here you open a bank account when t equals 0. T was your time, that was your months, with a balance of $500, and you deposit an additional $75 per month. And it said let b of t be a linear function that models the amount of money in your account after t months. So going back to section 1.3, that was on page 17, and we did that right here. But prior to t equaling 0, the account wasn't opened. So it wouldn't make sense to talk about your account values for any values of time less than 0. And to add to that, if t equals time, you can't have negative time. So that's another reason why we only went with 0. Can't have negative time. So a good domain restriction to put for that is t can be greater than or equal to 0. 0 would be when you first opened it, right? And this is a typo. This should be 500 here. I'm just realizing it. That was our beginning amount. And then any months bigger than 0, so 1 month, 2 months, 3 months, that would make the plus 75t happen. And we could graph our equation. But again, we wouldn't want time to be negative, so we could put a domain restriction. And then there was this other example about the oven on page 16. So the temperature of an oven over a 10-minute interval can be modeled by this equation for this. And so what was happening here is this was when we turned the temperature on, and then we only needed the temperature to run for 10 minutes. And so that's why we had a domain restriction. So again, since you're only going to heat the oven for a 10-minute interval of time, this function is only valid for 0 to t. 0 because you can't have negative time, and we don't need to run it for more than 10 minutes because we're just warming the oven. So keep that in mind as we go through some of these word problems. So on page 19, you are riding an elevator from the 10th floor of a hotel that's at a height of 150 feet down to the lobby at a height of 0 feet. The elevator travels at a constant speed and you reach the lobby after 30 seconds. So what kind of function would model this situation? How do you know? Draw a picture. So here's my building right here, and then this is the ground floor. So all the way here is my elevator, and I'm right at 150 feet. So everything over here, sorry you can't see that, will be representing feet. And then what happens is it starts to travel straight down, but it's over a period of time. So time is going to represent my x-axis. And as time goes by, this elevator is going to go down. Now the elevator is going straight, sorry you can't see that, the elevator is going straight down. But over time, it's actually going to look like it's going at an angle, which it's not. It's just as time goes by, the elevator will decrease in height until it gets to here at 30 seconds. Okay? So what I just drew there is a line. So this is actually a linear function. And how did you know? I just drew a picture. All right, so now we're going to write the equation h of t that would give your height as a function of time. So what we need is our beginning height, and we'll need our slope. Well, our beginning height, we started at 150 feet, so that's not a problem. But our slope will take a little more work. But we do know actually 2 points to help us get our m. We know that at the beginning, so when time was 0, our height was 150. There's one x and y coordinate. And then after 30 seconds, that's our other x coordinate, our height was 0. So what I can do is use my slope formula where I subtract my y's, and then I'll subtract my x's in the same way. And then I'm going to divide this so that I end up getting -5 over 1. So our slope is going to be -5. All right, now that we have that, we're going to write our function. So the height as a function of time, because the height depends on the time, will be I start at 150 feet and then I decrease 5 feet every second. And that will be our function. Now we're going to restrict this domain. So I don't need all the time in the world. First of all, I can't have negative time. So as far as time goes, the smallest amount's got to be 0. And then once the elevator hits the ground floor, I don't need the time past that. So that would be 30. And we do want to include those amounts because 0, you're in the elevator, that is 150, and after 30 seconds, you're still in the elevator. So we're going to include those. And now we're going to evaluate these. Now what we can't use is a graph, so we're going to have to use our function. So this is t, like x. We're going to put 6 in here. And notice it does say if possible, so 150 minus 5 times 6. And the reason why this is possible is because 6 is in this domain. I'm still in the elevator somewhere here in 6 seconds. So I'm going to have 150 minus 30, and that gives me 120. So my height after 6 seconds is 120 feet. Now the 40. The 40 we won't do because that is not in my domain restriction. So we're going to say h of 40 is not possible, and it's because 40 isn't in your domain restriction. Okay, So that is piecewise functions, or that's the intro. This is a linear function right now, but just one. So what a piecewise function does is bring multiple functions, and since we're only looking at linear right now, that's all we're going to look at. So in a piecewise function, you'll be graphing several pieces of various functions, hence the name piecewise function. So what I like to do first is look over here to the right of the semicolon and look at my boundary, my domain restrictions. And for one of them, x should be less than 2, and for the other one, x should be greater than 2. So the first thing, I'm going to frame out my 2. Okay, I'm actually going to grab a couple of different color highlighters here. So give me a moment to find one more color here. They don't always show up so well. So, here we go. So, this one, I will be graphing 2x minus 1 for where x is smaller than 2. But if you see how this points, that means I want it to have it on this side of the line. And then I'm going to graph the 5, which, here comes blue. We'll see how this shows up. On the, where x is greater than or equal to 2. So I'm going to put the blue here. So some people like the highlighters. I also like to do my reminder that 2x minus 1 will be on this side of my line, and 5 will be on this side. Now, until you get better, I'm going to recommend that you use a pencil. So what I'm going to do is graph 2x minus 1. So I will begin at -1, and then my slope of 2 over 1, which does tell me to go uphill, I'm going to graph the whole thing and then erase what I don't need. So here's -1, and I'm going to go up 2 over 1, and I'm going to keep that up until I have my whole graph paper filled. So if you notice, I could go ahead and connect them all right now, but what I remember is I only want this to be on this side. So what I'm going to do is erase the part that I don't need. All right, on this side, because there is not a wall stopping it here, I will put an arrow. And when I look at this one, this says don't include 2, so I'm just going to make it an open circle. Now 5, this is y equals 5, so we need to graph a line where every y coordinate is 5. And if you go up to where y is 5 and you draw a line, a horizontal line like this, every y coordinate on that line is 5. Like this is 0, 5, 1, 5, 2, 5, 3, 5, 4, 5. So you'll be graphing a horizontal line. But again, I only want, according to this, the part that's on this side, so I'm going to keep this part, right? I'm going to go ahead and draw an arrow there, and then erase this part. So when I'm done, I can only have one line on this side and one line on this side. Now, according to this, it says the underline include 2, so I'm going to put a closed dot. Now let's talk about the evaluating. You can evaluate with your graph or with your function. So with 0, the graph is very easy because I just go to where x is 0 and I see it's -1. But you could also use the function. You just have to see where does 0 fit. And since 0 is less than 2, I could put 0 in this function. So I could do 2 times 0. And when you do that, you get 0, and 0 take away 1. Well, that's the -1 that we already got. All right, let's check out f of 2. So f of 2. So 2 actually has 2 points here and here. So which one should we use? We should use the closed dot because this says include 2 and this one says not to. And we can see that it is worth 5. Now if you're going to use your function, where does 2 fit? Well, it's not less than 2. It's here. It's greater than or equal to 2. And then your answer's already done. You don't have to do anything. It's always going to be 5. F of 7. So again, I could go to 7, look up, and there's 5 again. Or I could realize that 7 fits in the same domain restriction and see my answer. And then 500, since it definitely doesn't fit on the graph, 500 fits in this domain restriction. So again, you get another 5 as your answer. So that's our introduction to piecewise functions. All right, let's finish this up. We are going to be, sorry, I got to switch parts here. Give me one moment. Let's take a look. And actually, you know what? I think I'm going to pause and I will just start a second video here.